So in this video, we are going to cover the LLD for Snake and Ladder game. As you guys are aware of this game already, so let's directly jump into the feature requirements part. Again, this is going to be a more of a simple thing. Um, as in the snake and ladder game, we have a board with some snake and ladder with some numbers. You can say kind of a matrix, and we have multiple players who can play the game there. So the basic requirement is just to have the board initialization. Another one, like we can have we should have the ability to have the multiple player for the game. Again, these are the things which are again normal in that game. Then there's a dice roll. So as you know, turn by turn, each player play the move, and based on that, they move the dice. Sorry, they take their moves on the board. And the next one is the game logic part. Again, the basic stuff. So I think we can directly jump into the design pattern stuff here. So again, the same thing. We are using singleton pattern, I think, in most of our design. So by using the singleton pattern, we are making sure that we are kind of limiting the access, the number of instances which we can create for the board. So in this way, we are going to create only single instance of the board. So I mean, everything is going to happen in the single board. So for that thing, we have used this singleton pattern to make sure all the interaction goes through the same board, and we are not having multiple things. And we also need to make sure that we are using the double locking or any other whatever way you want to use it, the reintrent lock or some other way to have it foolproof for the multi-threading system. Then we are having the factory pattern for creating these things like snake, ladders, or okay. For now, we in this, and you can even have one more thing which is cell also if you want to have. But again, we don't need to kind of over engineer it for at least for this one, because in this entire snake and ladder game, every cell is going to only have a number. So I don't think so. We need to create a specific class for that. But snake and ladder have some more things like the starting point and ending point. Similar goes for the ladder also. It always connect 2 points from. So for that we are using this factory pattern so that while initializing the board, we can place these snakes and ladder onto the board. Observe pattern, again, same thing which we have done in our almost all of the designs. So whenever there is a change on the game board, we are going to notify it for to the other classes. It can be for updating the scores. It can be to update to re-render the entire board which we see visually on the screen. Okay, it can be to notify the player also again that hey, now it is your chance, hey, now it is your chance, and all that thing. The next is the strategy pattern. So as you guys must be thinking, hey, why we are using the strategy pattern here? Maybe we can say this is a little bit more of a over engineering. Okay, so as you know, so let's say you are throwing a dice and you get a random number. So you are going to definitely use this random class to generate the random number from 1 to 6 or whatever. But we can have multiple strategies to even generate the random number. So this strategy pattern is actually used for those strategies that hey, we want to generate the random numbers by using that strategy, maybe some other strategy. But again, I think if you want, you can even ignore this because most probably we are going to use the same single strategy of the random class. But it's good to have this one. So if tomorrow you want to change the strategy, or you want to be a little biased, or maybe you want to play with maybe you want to make the game a little bit more biased and something like that, some little bit changes, then it can be done in from this strategy pattern. Basing the you can change the strategy by which you are getting the random numbers on the dice. And yeah, command pattern is, so as you can see in the entire snake and ladder game, what we are actually having is the movement. Basically, let's say you throw the dice, then there is a move command. Basically, we need to move the place from one cell to another cell. So that command pattern is actually used for that purpose. That is actually encapsulating the entire object, like how we want to handle that move command, what will be the new position, what was the old position. All those things are kind of figured out in the command pattern. We are like using the command pattern for that part. Now let's go to the code part. Okay. So as you can hear, we are having this obstacle factory. I think I'm not sure. Okay, I missed that part. But this obstacle factory is for creating the snake and ladders, basically. Okay, as you can just see if I want to zoom it out. So we are having this factory pattern. As I mentioned, we are using the factory pattern here for creating the snake and ladder. So we have created this class called obstacle factory, which in which we are having two functions: create snakes, create ladders. And tomorrow, if you want to have some other kind of the obstacles, maybe you want to update the game with new rules. Sorry, maybe you want to add some more stuff from your side in the game. That can be easily added. Although it will not be required since this is like a generic game, but still, yep. Then this is just uh, let me just say. So this is the dice strategy which I was seeing. Here we are implementing the two different rolling strategy. One is the normal dice, the same thing, the random. We will see the code how what we are actually doing here, and in this loaded dice ones. This is the command pattern which we are having. Here you can see we are implementing the move command. We are basically implementing this command interface which we have defined. Okay. If you see this arrow which says association, that means in board class we are actually using this move command. So as you can see, this implement, what does this mean? This implement part? This only means that hey, this class is actually implementing this. So this is how this entire graph is created. Wherever you see association, that means yeah, that means this class, sorry, this one is actually somehow somewhere used in this one. Or sorry, in the move command you will see. In the move command you will see that board maybe object is actually used there. And as I mentioned in the previous videos also, whenever you see the self-association, that means most probably it is going to be a singleton pattern which is used in that class. As you can see in this, there is a get instance method also, which is getting used there. Then there is a player class. I mean, like very normal thing to have, which have name, position. Which the player class is going to hold the current position also. The position of that, basically where its chances are basically on which cell that player is actually there. So it holds that one. And this game thing, if you see, this game class is actually observer pattern where basically we are implementing the observer pattern here. As you can see, add player, notify player, get current player, all those things, everything is handled in this game class. So now let's see the actual code. I think I've covered everything here. Yeah, okay. Just 1 second. Yeah. Okay, let's first maybe start with the observer pattern. So here, the normal implementation of the observer pattern, you first create the instance, sorry, interface, and then you extend the class, which we can see in this class basically. This is where we are actually using the observer pattern. This class is holding the list of the players which are currently playing. Okay, this is the player class which we have already implemented. I will show you that also. And this is the current player index. If you see the my previous video also, I have specifically mentioned it. If it's a multiplayer game, then it's always better to have an arrow, and then you can always have another index or the variable which is going to store which player is going to play the next move. Okay. This is just basic simple initialization which we are doing whenever the game start. Adding player, these both two operations are related to the observer pattern. So um, and this by this function you can get the current player. This is just the next one. Basically, this is going to update the current player index value. Nothing else. Okay, so this one is covered. Let's go to the command one here. Now, as you can see, just a basic way of implementing the command pattern. Now let's go to the move command. So in this move command, we are having this initialization with this move command where we are passing the player, the steps, and the board. Steps is nothing, just the number of moves, the basically the number which a player have got onto their dice. That is what is specifically mentioned here. And we are providing the access basically class of the board also. This one. Here we are implementing the method execute, where we are mentioning, where we are kind of fetching out the next position of the class, and we are also checking out here in the same function that whether there is a snake in the path of that or not. Okay, we will see in the board class how that snake and the ladder is actually getting stored. So if you see here, this one here, we got the new position simple by adding the number, like since the matrix is formed in something like this way. Okay, one comma, not one comma, I would sorry, one comma two comma three comma four. Okay, then you can just say eight comma seven comma five comma six. So sorry, I just made a reverse thing here. Yeah, so you are here, let's say at two. Yeah, so let's say you are here at 3. Now, whatever dice number you have got, you will just add to it and you will get the final location. That is what we are doing here. Okay. Again, the basic check which we are trying to do. As you know, if you go above 8, then definitely you have got a win. So that is what, this is the basic check we are having. This is the function where we are trying to check whether whether there is a snake or not, whether there is a snake or a ladder or not in that entire journey. For example, when you will move from 2 to 7, there can be a snake in between, or there can be a maybe a ladder in between. So that is what we are actually um, trying to check here. Okay. So it says board dot get snakes. As you can just see from the method name, actually we are getting all the location of this get snakes, and we are checking whether our new position is held there or not. Okay, sorry, I missed up one thing. So in the game, basically, the point where your position gets stopped, let's say you throw the dice, you got 4, and you are moving from 3 to 7, let's say. So wherever you stop, that is from that cell we count whether there is a snake or ladder, not in the entire journey. I think that was like a little bit forgot about the game. So that is what we are doing here basically. We fetch all the locations of the snake, the initial locations of the snake, from where it will bite and you will get descended to the lower cells. We are checking whether this new cell is there or not. If it is there, then we update the new position. If the ladder is there, again we update the position and we set the new position in the player class itself. So in the player class, we are holding, as I told you initially also, in the player class itself, we are holding their position, like wherever they are currently in that matrix of the snake and ladder. Okay. Now let's go to the dice strategy which we are having. A simple basic implementation of the strategy pattern. We have implemented the interface, and then we are going to implement this normal dice and this loaded dice by implementing this strategy, dice strategy. Okay, if you see this normal dice, as I've mentioned, we are just going to use this random class to generate the integers from 1 to 6. Okay, so that is what we are doing here. Then the next one is this loaded class. So if you see, for now I have just created a kind of a sample here to showcase you that hey, how we can have a different strategy. But this is not exactly, I mean, what we are just saying that hey, now as I told you, we can have a little bit biased dice also. So this is what, so here we are actually generating the numbers which will be generating by this strategy would be only between 4 to 6 as mentioned in the comment also. Okay. So the change between this and this is only in the roll dice function, as you guys know that's the way basically the strategy pattern work. Now let's come to the player class. I think yeah. Okay, here. As I said, the player and that board is actually was using this observer pattern. So here, if we go to this observer, this one and this one. So what happens is uh, whenever there is a how should I say it basically, yeah. So whenever there is a basically update in this player class, we are calling this function update. I will showcase you that also. Where are we actually doing? I think we have gone through it. So say here. as I said. So here, if you see, this player class is having this update method, okay? And if we go to this game class, as you can see here, whenever there is a change in the status, we are actually notifying all the player that hey, there has been an update in the game. So we are iterating over all the players and we are updating to them that hey, this is the update which is there basically. So you can see it. It can be, you can say, we are updating it to the all the one of the use case maybe to all the screens of all the players. Like maybe different player can have a different screen. Just for an example, say for now. So the update will reach out to all the players in this way. If they are having a different screen, kind of you can just say hey screen render here and that would work. So that's how we are doing it. That's how this observer pattern is actually working. In this player class, we are having this update function, which is actually getting called with this game whenever there is an update, basically. Okay, now we will see also who is actually calling this notify players. Okay, here we are registering all those players who we want to inform about the update. Okay, here this is the function which we are using, and this is the basically first call, which is actually triggering that entire observer pattern. When whosoever call this notify players, it will provide a message here that hey, this is what the update is, and it will be traversed to all the players one by one. Then the way we normally do it. Okay, so this is how we are doing it now. We are done with this. We are done with this class also. Okay. Obstacle factory, yeah, I think we can come to this one. So again, we are just using the simple basic factory pattern here to generate the snakes here. We can even have a simple one function here. We can something say like static void create obstacle board. Okay, and when then we can provide the type here basically. We can even do that also, but if tomorrow, but the thing is, if tomorrow we make a different class for these snake and ladders, then it may become a problem basically. Right now, in this existing code, we have not actually done it. We have not created the snake class or we have not created the ladder class in this one. We are actually just putting it to the board directly, putting it to the board class basically, mentioning that hey, this is where the snake exists and this is where the snake exists. We can create a different class for snake and ladder, but at least for this use case, it's not required. And why to waste the space? Like we are going to actually end up wasting the space if we are going to do that, since it's going to take extra space, and we still require the matrix one, this board one basically. Okay. So we are doing that. We can do it this way also because here, as you can see, these are exactly same. I would say both of them have the same thing. We can even have the same one function which can do both the things for us. We can just define the types. But again, there is no issue with having two functions, so it's fine. Okay, now let's see the main class, which is the board class, where actually everything is there. Okay, one thing is we have not created a matrix in this board class the way I was explaining it to you because it's not required. As we know that the way this entire board work is, it starts from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and just goes from bottom left to the bottom right in the kind of a zigzag way. So do we really need the metrics for that? I mean, we know the numbers are always going to be 1, 2, 3, 4, 5. I mean, the moves are always going to be like based on the dice. That's the reason we are not having that matrix because it's going to take extra space which is not required. And what about storing the snakes and ladder? That we can easily do by having a pair of even in the array. But in that case, it will be hard to find out where the snake is, whether the new position is in the whether the new position belongs to the snake or ladder or not. So that's why we have created these two maps basically. They both are holding the positions of the snake. So this integer is the starting cell number and this integer is the ending cell number. Same goes for this ladder. Okay, for example, if I just go back to this one. So if we see this one, so let's say if this is one, then two, then three, then four, then five. So just let this snake. One, two, three, four, five. So we are just saying, hey, we have a snake from five to let's say some other number. Let's say 10, 9, 12, whatever it is. So that is how we are storing. Same goes for the ladder again. Why we again we can even have a combine of this also, but if tomorrow we want to have the right now we have not introduced the scoring part, but definitely the scoring for the snakes and the ladders are going to be different. That's why I kept it we have kept it different because they are both are actually different thing. Right now you may think of that hey, we can have a single map, but tomorrow if we are trying to fetch anything or change anything in the design or we want to add some more feature, it will become really hard for you to do anything. For example, if we just think about adding the score, it will not work out because if you store everything in single map, you will not get to know whether to decrease the score, whether to um, increase the score. Even that logic will not work where we were checking whether it's a snake or ladder. If you remember in the move command, we were doing the calculation part. Okay, simple constructor where we are initializing the board. Singleton patterns I mentioned before. Basic getters and setters actually. So nothing fancy here. Let's say. Let's see if we have not covered anything as such which we should really cover. There are multiple optimizations and the improvements which can be done still in this entire code, particularly about the space optimizations for sure. We can really compress the space in many ways. Okay, like while storing all these snake and ladder thing. If the board is small, it's fine, but then once the board becomes, let's say if I say 10 to the power into 10 to the power 9, it will become too much. Okay, let's now go to what I think in the code wise, we have covered everything. Let's go to the second part. So let's talk about the issues in the above design. So definitely the above design is mostly going to work on the single threaded system. Even if you see this one, if you use this way of implementing the singleton pattern, this is not going to work on the multi-threading system because two threads can enter this get instance function at the same time and they will initialize two boards. So this is one of the things which we definitely need to improve. Not on this front only, not on this front, but it will be on every other front also, like players' actions and the improvement. Like if we are having multi-threading, we may see that multiple players are making the chances concurrently. I mean, they will be able to do it in the current design, not because we have designed it in such a way, but just because this does not support the multi-threading correctly. They will mess up with their each other's scoring. Maybe something can go wrong. So, I mean, let's say we want to have make sure that, for example, one player in this game, since see in this snake and ladder game, there we can say that hey, multiple player can play their chance at the same time. No one needs to wait for each other. Right now, it is that way actually. We are checking who is having the next turn, and based on that, we are deciding who will picking up the thing. I will show you actually. I think we messed up that part where we need to show how we are actually taking the user's input and all. That will cover after this one. But right now we were taking their chances one by one, but they all can start even at the same time. This is their actions are not dependent to each other. But in the code, the way we have implemented, yes, they are. Again, as I've said, that this may not scale well with the large number of players or the extensive board sizes, or even if we want to have the multiple board games together, since as you can see, we have used the singleton pattern, which only allows the one instance of the board. Okay, this is something we have design mixes, game logic. I think what I feel right now is, I think we can even ignore this based on what we have in this game. I feel it will be a little bit more over engineering in this design. But yeah, I think we can still discuss about what can we do better. Maybe not in it may not be very helpful for in this case, but maybe some other ones. Okay, so all these things are basically we are covering this already in our course. That's already there in the blog. So about the limited extensibility, for example, as I said, one thing was about having the multiplayer. They are taking the chances at the same point of time. Okay, currently we are not even having the scores. Okay, I'm not sure we have not looked the design in that way yet, whether how we are going to update the scores and all those things. So that is where we are trying to say here that adding new features or modifying the existing one may require significant code change. This is again specifically covered in the course. Like what do we mean by like what are those classes which we are really pointing out here? Performance bottleneck. Okay, so this random number generation and frequent lookups in May. So if you see, we are having this frequent lookups here. It was in the board, I think. Wait, it was in move command. Yes. Okay, so all these are we are having this frequent lookups to the map. So because if you go to the board and you see the snake and letters, these are having the map and we are having the frequent lookup. So they can be performance bottleneck in future if we are having a let's say if we are having multiple boards together and we are having multiple players, maybe millions of players, just for an example sake, at least for now, that can become at least a performance issue if we are having that frequent lookup in the map. Okay, random number generation. Again, basically what we are trying to say here is the number generation, the way we are generating the random can also become a bottleneck. In actually in our paid course, we have actually shown what can be the other way of generating the random numbers in more optimized way, which will affect the performance in a least way. Okay. So again, we have resolution can be using the more efficient data structures, optimize these operations and all those things. I think it's the same thing which we have covered. Yeah, one more thing is saving and loading the game state. So what happens normally is, let's say, some players were playing the game and now they want to hold it. For example, if you have played the GTA San Andreas and all that GTA games, they have the feature that you can always resume the game. What if we want to have it here? In current system, definitely we can't have it. So we need to have that feature where we can any point of time save the current status of the game and later on load the status again. Current system does not cover that, but that we have specifically covered in our premium course, as I mentioned here also. Okay. AI player, same thing which we have discussed in the previous section also. We can introduce the AI player here, where a AI player and a human can play. Actually, there's nothing much a AI player even can do here. Just a random number generation, but just for the sake of maybe I interview may ask you in the interview, since the AI is like everywhere now. Okay. This one is more about actually we need to what if we offer different types of dice with different number of faces. Currently, what is happening is we have an internal strategy to generate the random number for every dice whenever a player roll the dice. But what if we say users, or we are going to ask users that hey, you can decide which dice you want to go with, a biased dice or unbiased dice, just for example's sake, or if you want to have a different number of phases. See, this is like a digital game. In physical game, it may not be possible. In digital, it is highly possible. That what if you want to have only four faces? What if you only want to have 10 faces? Something like that. Maybe 10 a dice with a number from 1 to 10. So that is currently definitely not supported. I mean, player, we can't say that in the board initialization at the beginning of the game that hey, this is the type of the dice which you want to use to play the entire game. So that is what we are actually trying to mention here. The way we are currently implementing the game, it's not actually correct in terms of rules, the way we are defining the rules. So if you even saw that thing here, move command, it's just a random, like we are just writing the code directly here. We are, I mean, if tomorrow we want to change anything, we will have to actually come to this function and change it. Instead of that, the rules based on which we are calculating the scores and all these things actually should be based on the rules. We should have some configurations to do. Okay, that is what we are actually talking here basically when we say enhance game rules, add optional and customizable game rules. Currently, the system does not support it basically. If we want to have some extra rules tomorrow, for example, if you must have seen like whenever you start a new game, there is always some customization of the thing you can do that. Hey, do you want to have this rule included in the game that a player cannot kill each other or kick each other? So just saying them randomly, but the same kind of thing we can have in this game also. Current design does not support it for sure. Okay, maybe penalizing for the specific squad. What if you want to say, hey, if someone gets six or if someone gets four, if someone gets two, we want to penalize it. Like it's a kind of a digital game. You can have a different rules for different games. So that is what we went to say here. Same thing as I said, allowing the players to configure the rules at the starting of the game, basically when they initialize the board. Yeah, as I said that we are not covering the scores currently, not even the leaderboard. So that is again we can add it. Again, we have covered it already in the our premium course. I think this part is covered. One thing which I forgot at the last was how we are implementing this entire. We discussed about the entire code, but we forgot how we are running this code thing. So let's cover that part also. So if you see, we are using the singleton pattern. Basically, we are trying to access the singleton pattern class, and to get the initialization of the board, where we are having the size of 100 into 100. Okay. Once we have got the board, basically this is what we are saying. We are building the game now. This is kind of a starting or the generation of the game. We are preparing the board for the user. Again, this code also can be kind of improved in a very great way. But for the sake of showing you how we can use these existing classes, we have done it this way. So as you can see, we have used the factory pattern to create the snakes. And that, as if you remember, in the factory pattern itself, we were updating the board there. So initializing the players and all that thing, adding the players to that observer pattern thing. Okay, creating a die strategy what we are going to use, and this is how we are implementing it entirely. Whenever you are mostly playing the game, it's mostly you use the while loop with the true. So game will keep going on until you come to some end. Maybe either someone's win or someone's is out, or mean something happened. Okay, this is just we are using to we are calling the game class, which is actually this one, to get the current player. Okay, that will be always initialized to zero at least in the beginning. Then you roll the dice here. Here you can even say that, hey, maybe take the user input from some other physical hardware. What if tomorrow you say, hey, I want to attach a physical hardware to this game? You can just write here. You say that, hey, input will be coming from that physical hardware. And that's how you can kind of keep going with the other part of the code, basically. There's just a move command we are thing, executing it, notifying the players about the change which happened. If you see clearly, you will get it. What we are actually notifying. Hey, current player have rolled a dice and he has moved to this new position. That's all. This we are actually notifying to all the players. Basically, this is the winning condition. Okay, if the new position is hitting the um, end of the board, then we got a player win and we are breaking it out of. We are calling this to basically move the that index. This is just done to move the index to the next pointer. This one basically incrementing, kind of incrementing. If you see here, that's one basic thing which we use. If the number is going above the player array size, then start from zero. For example, 0, 1, 2, 3. After 3, no one is there, then definitely the next chance is again from zero. Okay, so that is what I think it's here. I think we have covered everything now. Let's see if we are moving. Yeah, I feel we have covered everything from this perspective also.